Welcome to the best resource online for learning about building microservices with Node.js and React. My name is Stephen Greider, and I've been working as a professional software engineer for the last 12 years. I created this course to share the knowledge I've gained in this time with you. Microservices are a hot topic in the development community. This course will teach you everything you need to know about building them. The only previous experience you need is basic of Node, Express, and React. Building microservices is tricky. To do so, you need to understand the full tech stack. Everything from front-end apps, to servers, to databases, to deployment strategies, and more. And that might sound very scary, but I've got great news. This course is to walk you through every single step. I've taken great care to ensure that you will see every last of building a microservices app from scratch using a minimal number of outside libraries. Along the way, you will build your skills with technologies like MongoDB, Docker, Kubernetes, and TypeScript. You will deploy your app to the cloud, where your friends and users can access it. You will even set up a development cluster in the cloud, where you could develop dozens of microservices at the same time. It is all here, all inside this course. Every bit of code that we write is focused on being used in a nation setting. You will not ever hear me say something like, "Don't do this in a real app." Instead, all the code that you write in this course can be used immediately in real projects. I can say with absolute confidence that there is no other course like this online. This is the only course online that goes into incredible detail on building every aspect of a microservices app. So don't wait any longer. Sign up today and learn to build complex, scalable microservices. Sign up today and build the app of your dreams. Hello and welcome. My name is Stephen Greider, and I'm going to teach you everything I know about microservices inside this. We're going to cover a tremendous amount of content, and we're going to get to it very soon, but first, just one quick administrative note. If you get stuck at any point in time throughout this course, there are 3 places for you to go to get some help. First place to go is the Udemy QA discussion boards. If you are running into some issue, chances are someone else is as well. So check out the QA discussion boards, and you might even find a solution on there right away. Failing that, you can always reach out to me directly through Udemy, or you can reach out to me through Twitter as well. I usually respond to questions for about an hour or 3 hours every morning, Monday through Friday. I almost never get around to answering questions on the weekends. So if you ask me for a question on the weekend, you might want to follow me on Monday just in case. Okay, so with all that in mind, let's take a pause right here and dive into our first technical topic in the next. All right, my friends, in this video, we're going to try to answer a very simple question. What is a microservice? To answer this question, we're first going to do a quick review on how you are probably building servers right now. So right now, you are probably familiar with a monolithic architecture. This is probably how you are building servers right now. In a monolithic server, we have all of our code needed to implement our application inside of one single code base, and we deploy that code base as one discrete unit. So we might imagine that with a monolithic server, we have some request coming from a user's browser or mobile device that will flow into our application and go through maybe some pre-processing middleware. Then it goes off to some router. That router might then inspect the request and decide to send it off to some very specific feature to be further processed. So maybe in this case, it goes off to feature A, and feature A might decide to read or write some data out of a database, eventually formulate a response, and then send a response back to what made the request. So if we had to characterize a monolithic server, we might say the following. We might summarize it with this sentence right here. We would say that a monolith contains all the routing, all the middlewares, all the business logic, and all the database access code required to implement all features of our application. So that would characterize a monolith. Let's now take this diagram right here. We're going to make 1 or 2 changes to it, and that will then summarize or characterize what microservices are all about. So here's how we would characterize microservices. We would say that a single microservice contains all of the routing, all the middlewares, all the business logic, and database access required to implement one feature of our application. That is the big difference. So a monolith has all the code needed to implement every feature of our application. A microservice has all the code needed to implement just one feature. So let's take a look at it in a more kind of visual format. All right, I know this diagram is a little bit crazy, but it's very similar to the one we were looking at just a moment ago. So with this microservice architecture, we've now split off all these different features and wrapped them up inside of their own little personalized services. The very important here to understand is that each of these services are entirely self-contained. So service right here has all of the code required to make feature A work correctly. It has its own middleware, it's got its own router, and it even over here, kind of surprisingly, will have its own base as well. The nice thing about this approach is that if for some reason, if every other feature or every other service inside of our application crashes or just mysteriously disappears, a portion of our app is still going to work just fine. Because service A is 100% standalone and doesn't necessarily require any other service to work correctly. All right, so that's a very basic kind of introduction to answering this question of what is a microservice. Our working definition for right now is going to be that a microservice contains all of the code required to make one feature work correctly. Now that we've got a working definition, we're going to take a quick pause. We've now got a working definition of what a microservice is. Now, at the end of last class, we were looking at this diagram right here, and when you were looking at this, you might have said to yourself, oh, okay, microservices are easy. All we have to do is take a feature, wrap it in a service, and that's it. Well, unfortunately, reality is just a bit different. It turns out that when we start working with microservices, there are some really big challenges. So here's what it is. Data management between services. When I say data management, I'm talking about how we store data inside of a service and how we communicate that data between. Let me take a pause right here and just tell you flat out, this is a very challenging problem. It is a huge obstacle to effectively using. The good news is that this problem right here is what we are going to have an unending focus on. And by the end of this course, you're going to have a couple of different strategies for working with this data management problem. So now let me tell you a little bit more about why this is a problem. Let me help you understand why this is such a big thing. Okay, so a little bit of preamble here, a little bit of background. With microservices, the way in which we store data and access data is a little bit weird. And what I mean by weird is that it's just a little bit different than what you might be used to. With next diagrams, we're going to take a look at how we store data, how we access data, a microservices approach. So first off, how do we store a microservice? We might recall the diagram we were looking at just a moment ago. I showed a database for service that we had created. So whenever we are making use of service, we separate database for each service. If the service actually needs a database, that's fine. We're not going to give it one. But the point is, every service gets its own. Now that might sound really strange, but I'm going to give you a very good reason for just a moment. First, let me also show you how we access data. And once again, this is going to be a little bit strange. To access data, I'm not going to tell you exactly how we're going to access data. I'm going to tell you how we are not going to access data. So we are never going to access data by reaching another service's database. So under no circumstance ever right here, try to reach into the database for service B. And once again, I'm going to get this in just a moment. Okay, so in total, there are two big kind of surprising facts that I've now mentioned. First off, each service is going to get a database if it needs one. And secondly, services are never going to reach into another service's database. So now I'll tell you why are we doing this, because these seem like two very strange rules. So reasons. First, I want you to understand that this whole idea of giving every service its own database is known as a pattern. The pattern is called database per service. So as you'd expect, that just means every service has its own database. But here are a couple of reasons, and this is by no means an exhaustive list. And this is the really big reason, is that we want every service we create to into services. So let me show you a quick diagram to help you understand why each service is going to help with that. All right, so first, let's imagine a scenario where we have every service using the same common database. So maybe one database right here will database for everything. The problem with this approach is that if anything bad ever happens to the services are going to crash immediately. The other big problem is that scaling is really challenging. If every service inside of our application uses the same database, you have to in a database instance or that one database to service all the services. It would be a lot easier to scale just the databases capacity. The other scenario that we could run in, let's imagine that we've got service A reaching out to database B's service right here. If anything ever goes wrong right there, then all of a sudden, service A is going to start to crash because we enter data between service A and service B. So if a request comes into service A and reach over to this database and something is wrong with that database, boom, service A is going to crash as well. Instead of just losing service B, we would now also be losing service A. By giving each service its own database and making sure that each own database, we dramatically increase the uptime of our entire system. Now, next reason, let's see right here. So next reason that we have this data is that the schema or structure of the database might change unexpectedly. So this as well. I want you to imagine for a second that we've got service A reaching directly to B. Again, this is not what we want. I can give you an example of why we do not do this. So let's imagine that feature A usually runs a query of something like get user inside of B. And usually, data be an object that has a name of Jill or something like that, whatever the name is that it's got a key right there. And let's imagine that for some reason, service B, the team that is in charge of it, decides to change the schema or the structure of this database. And maybe decide every user and name property. Maybe they want to call that first name instead. Let's further imagine that maybe the team in charge of service B does not tell service A about the change schema right here. If that were to happen, then the next that service A makes a query down here, they're going to get back an object that has first name. Service A was probably not configured to expect. And so now we might start to have some issues start to arise in service A. All because to rely upon a database located in a different service, and that second case right having a change at some point in time. Throughout here is that some services might be able to function more efficiently if they are using a different type of database. So the service can run more efficiently if it uses Mongo or MongoDB as opposed to similar to that. The whole database per service pattern might seem promising. You might already be saying, Stephen, there's no way this is how it's done. There's no way we're separate services. Well, this is reality. This is how every successful engineering team out there is using microservices. They are all, every last one of them, following this pattern here, or service. Okay, so now that we've set up this kind of weird pattern right here, we really touched on why data management between services is really challenging. So quick pause and start to expand on this in just a moment.